Hello, today we're going to be using this device to investigate the relationship between the pressure on a gas and the volume of that gas. We are going to be trying to confirm Boyle's law, which states that for a fixed mass of gas held at a constant temperature, if we multiply the pressure by the volume, this will give us a constant. So within the device I've got a constant mass of gas. There is a glass tube containing a volume of air, and I can see the volume of air by reading off the scale in centimetres. The bottom part of a device can be connected to a pump and the pressure can be read from this scale here. We're going to be looking at the red markings, which are in newtons per metre squared, which is the same as pascals, and it's times 10 to the power 5. So at the moment it's just over 1 times 10 to the power 5, which is 10,000 pascals. The orangey yellow liquid here is oil, and that's what's going to change the volume of gas in the tube. You'll also notice that there is a thermometer. This is because this relationship is only accurate at a set temperature. I've now connected the device to a bicycle pump, and as you can see, when I increase the pressure, you can see that the pressure gauge goes up, and you can see that the volume of gas is being compressed. So the volume of the gas is decreasing. As I carry out the investigation, I'd like you to make a note of the results. So you're going to need a table which has 3 columns on it. And the headings are going to be pressure, the first column, that's going to be in pascals. The second column, the heading is going to be volume in centimetres cubed. And your third column is going to be the pressure multiplied by the volume. So that should be a constant throughout the whole experiment. It may not be though. You may want to pause the video now while you sort your table out. The first reading I'm going to take is at 30,000 pascals. So I've already pumped it up to 30,000 pascals, and we should be able to see that the volume of gas, can read off the meter, is 22 centimetres cubed. There's a valve at the side here which I can unscrew and release some of the pressure. You could see the needle on the pressure gauge going down. I'm going to release the pressure until it's at 25,000 pascals. Now the gas is at 25,000 pascals, we can see that the volume of gas is actually 27 centimetres. At 20,000 pascals, the volume of the gas is 34 centimetres. At 15,000 pascals, the volume is at 46 centimetres. And finally, at 10,000 pascals, you can see that the volume of the gas that's just gone off the scale is actually about 67 centimetres cubed. During the recording of this video, it was sometimes quite difficult to hear what I was saying when I was talking about the volume of the gas, and it sounded like I was measuring the volume of gas in centimetres. This is just because I was stopping the microphone too early, and you must make sure that it's always in centimetres cubed, not centimetres. Now that the investigation is over, you should have your table complete, and you should be able to confirm whether the constant was indeed remaining the same throughout the experiment. The second thing I'd like you to do is to plot a graph of volume in centimetres cubed against pressure in pascals. Your results should show an inversely proportional relationship. This is where when one of your variables doubles, the other one halves. Thank you for watching this video. Now it's time for you to go and do the work, and don't forget to submit a photograph of it to show my homework. Goodbye.